In last video I told you about compound microscope and the diagram of compound microscope. Today we will derive the expression for magnifying power. So we know that magnifying power means 10 beta by 10 alpha, and from the figure already in last video I told you that this is angle beta. So if this is angle beta, from the figure it is clear that beta equals to, we can take this triangle, and if it takes so, then perpendicular by base. So perpendicular is a dash b dash, which is I have written here a dash b dash divided by base. Base is this one, this is ue. Why this is ue? Remember that wherever I have written u o or not, that means o stands for objective. So this is the object distance of objective lens, this lens. Okay, whenever I have written UE, E stands for eyepiece. Which lens is eyepiece? This lens. So for this lens, object distance. For this lens, where is the object? This is the object. So how much will be the distance? This much from the optical center to this. Okay, that is UE. Alright. So 10 beta is A dash B dash by UE. Done. Next, 10 alpha. And as I told you, alpha is the angle made, is a visual angle when no instrument is there near our eyes, just with naked eyes. So suppose this is this is the eye position, this is the object should be at which place? 25 centimeter means capital D, least distance of distinct vision. So in this case this object is making how much angle? Alpha, right? So 10 alpha will be how much then? Perpendicular by base. So perpendicular is h naught, and h naught is nothing but this term, this one is h naught, right? Object, height of object, h naught. So nothing but it is ab, we can write that. So here I have written h, instead of writing h naught by d, I have written ab by d. Okay, now from this one thing we can do, this a dash b dash by ab, what is this? This is the ratio between image and object. For which lens? For the objective. So for a lens, the ratio between image to object is not the, it is known as the magnifying power. You know this one. So this will be this ratio a dash b dash by ab. That will be the magnifying power for which lens? For objective. And that is why in this place I have written m naught. It is the naught means, or mo, o for objective. This one is the magnifying power of the first lens. Apart from this, what are the terms that will remain here? D will go up, so D by UE. Now D by UE, isn't it ME? For, if you remember, for simple microscope, in last video I told you that this part of the microscope is behaving like simple microscope. Now if you just consider one lens, this is behaving like simple microscope, isn't it? And in simple microscope, what was the formula for magnification? Du by UV. That is the magnification or magnifying power for which lens? Of this lens, eyepiece. So here in place of D by UE, we can write ME. ME is the magnifying power of which lens? Of eyepiece. Where from we got this? We got it from the formula of simple microscope. I think this much is clear. So next let us see. Okay. That is the general formula, this one. Okay, that is magnifying power is nothing but it is the product of magnification of eyepiece into magnification of objective. Next one, spatial cases. Case number 2, just like the previous cases, maximum magnification. Maximum magnification takes place in which place? When the image is at least distance of distinct vision. We know this one, that is image is at D. So if the image is at D, object is minus QE, image is minus D, minus because all the things are taken in left hand side. Okay, and focal length, here since two lenses are there, the focal length of eyepiece will be given by FE, the focal length of objective will be given by F naught or FO. Then these things are substituted in this equation, that is the lens formula, 1 by F equals to 1 by V minus 1 by U. Okay, there if you substitute, we are going to get this value. Alright, so this thing, this formula, we are going to substitute in this equation. Alright, m naught will remain as it is, magnifying power of objective. Magnifying power of eyepiece, that one was d by ue. D will remain as it is. In place of ue, ue means it is actually 1 by ue, right? So 1 by ue means which value? This value. We can substitute it here in place of 1 by ue, and this d will get cancelled. Here we will get 1 plus this d will go up, so d by fe. So finally, which formula we are getting? This one. Another modification, m naught, this is what? This is the magnifying power of objective lens. So if you remember, magnifying power, we have a just a second, magnifying power, we have a formula v by u, right? But we are talking about objective, so mo will be, vo by uo, v naught by u naught, this one. Okay, all right. So this can also be another equation for magnification, this one. Then okay, one thing, see here, this part we can keep as it is, but there is little modification again. V naught is nearly equal to L here. L means we call it the length of the microscope, means it is the distance between the objective and eyepiece lens. Okay, I will just go in the diagram and I will tell you why it is approximately equal. V naught is approximately equal to L and U naught is approximately equal to F naught here. See, L means which distance? This part. The separation between the lens. But in practical case, as I told you, that this object will be formed in between the focus and the optical center. That means it is very close to the lens. Though in the diagram, since we have drawn it in different scales, it is not looking like it is very near to this lens, but in practical case, this image will be very near to the lens, because it should be in between the focus and optical center. As a result, what happened is, if this is too close to this much length, L, length of the L means it is the separation between both the lens or length of the microscope, this L, it is nearly equal to what? V naught, because this thing will be very near to the lens, somewhere here maybe. So see, if this thing is here, this is V naught, no? So V naught and L both are very close to each other, very nearly equal to each other. So that is why this condition is applied. Another condition is applied here, this one, no? V naught equals to nearly L. U naught is F naught, this one. U naught means this is the object, naught means objective lens, so this is U naught, this one, this much is U naught, and which is also very nearly equal to the focal length of this lens, because the focus of this lens will be somewhere here, maybe here. So focal length is this much is focal length. Okay, so this focal length and U naught are nearly equal. This is just an approximation, not exactly equal, but to solve some sums, we can take this approximation. So this part you remember, that this can be a condition. Okay, and if it happens, in place of U naught, what we can substitute? We can write F naught. In place of capital in place of V naught, we can write capital L, like this. So this is another formula. Alright, this is for this adjustment. Now another adjustment we have, that is a normal adjustment, this one. So in last case also I told you that normal adjustment means relaxed eyes, our eyes, there will be no strain in eyes, and the image should be at infinity. So which condition we are supposed to apply? Just see this condition. U will remain as it is, U is minus UE, no problem. V, this time it was D, because 25 centimeter, but this time V is infinity. And thus if you apply this condition in lens formula here, what we'll get? 1 by infinity means 0, right? So we get this one. So this thing means UE equals to FE. So the general formula, what was the general formula? M equals to M naught into ME, and ME is nothing but D by FE, right? So okay, D by, it was actually D by UE, but in this case UE and FE are same, so we can write D by FE, and this part will remain as it is M naught. So M naught means this one only, V naught by U naught, same thing, just only change will be, in place of this term we are getting this term now. Alright, this one, no, general formula, how much we got, this one, it was d by ue, but in this m naught will remain as it is, but in this case what we got, ue equals to fe, so it becomes d by fe into m naught, this one. Okay, this part. Another very important thing that you can remember here, length of a microscope L, it is equal to distance between both the lenses, just now I told, and it has a formula, is this one, modulus of V naught plus UE. This thing also you can remember, this formula, modulus, because here no sign convention is taken, we are just taking the distances, the lengths, so that is why this formula also you remember for compound microscope. Okay, sometimes it may be used to solve some sums. Let us see one sum. Compound microscope has an objective of focal length 2 cm and an eye lens or eyepiece, same thing, eye lens of focal length, this one. Okay, if the object is placed at 3 cm from the objective, that means it is u naught, the final image is formed at least distance of distinct vision. Find the magnification produced. Okay, find the magnification produced. So these are the things given. In the question you can see, in the question it is given f naught is 2 cm, fe 5 cm, u naught is 3 cm. Final image is at d, means 25 cm, because here one thing you see, this part, no, final image is formed at least distance of distinct vision, so that is why we consider that final image is at d, means 25 cm, this one. Now for magnifying power or magnification we have this formula, when final image is at d, then you just substitute the values. Once you substitute the values, this one, what we are going to get from here, we are going to get this equation, right, this equation. Now here in this formula V naught is unknown to us, we don't know what is the value of V naught. Once we know V naught, we can find out the magnifying power. So to get V naught, we are going to, or we are using lens formula, 1 by f naught equals to 1 by V naught minus 1 by u naught. 1 by f naught is known to us, 2 cm. But remember, in this formula we will use sign convention, lens formula. Generally in lens formula we always use sign convention. Okay, so f naught, it is convex lens, so it is plus 2. V naught that we are finding, we'll keep it like V naught only. U naught, u is always minus, right, towards left it is, so u, though it is 3, while substituting here we will substitute minus 3. Okay, then you do the calculation and you will see that V naught comes as 6 cm. This value of V naught we are substituting in this equation. Okay, here, and thus we are getting magnifying power as 12. Magnifying power, it is not having any unit, so simply we will keep it as 12.